Alrighty, this week we're going to be doing lesson 9, but some of it is not available to you yet, and that's because I don't want you to start on it until Wednesday. We get a chance to talk about these things. So some of this, we're not going to have a guest speaker yet though, so I'm going to make that one go away, hopefully. So anyways, lesson 9, we'll really get started on Wednesday because we'll have everything ready to go then. And today we're going to do a different kind of activity. Lesson 10 is also this week, sort of, and that's our unit exam. So this is our unit 2 exam. The project, the hands-on thing, is for triangles. So it'll be kind of like the rectangle thing I asked you to practice with last time, only you'll be doing rectangle shapes with nested loops instead. The exam itself is just the 2 chapters that were if statements and looping. So it should be pretty limited in the multiple choice questions to just those things. Remember, the types of multiple choice questions that are going to get you about looping are going to be the one-off errors. And a one-off error is where we as a programmer forget to take into consideration that we started counting at 0, or where we forget that we started counting at 1, but however we start, we end up off by 1. And that's kind of a common thing in this exam. Other than that, everything's pretty straightforward. So if you notice, those are both dated for Monday. So on Monday morning, first thing, or well, Monday afternoon, first thing, I'll have you guys show your 4 triangles projects, because we probably will have some different ways of accomplishing that task this time. And then as soon as we're done looking at your 4 triangles, we'll start the unit exam, and it should be pretty quick. Multiple choice, I think there's 40 questions. So that's what we have coming up. So for today, we had talked about the rectangle program challenge that was on Programmer. And I wondered if anybody had a solution that they wanted to share. I'll stop my share so that we can have somebody jump in there and let us see what you got.
Which program were you talking about, Ms. Riley?
The rectangle. Last week was like, oh, here's how to get started. Everybody get this done. Now, if we need more time, that's fine. I'll let you take a look at it more. If you can't remember it was in lesson 8, the programmer challenge, the rectangle. I don't know if that programmer site is going to load for us. But you had some different things you could do with your looping. Well, if nobody has it, then let's open Visual Studio. That's unfortunate because it would be helpful for you if you had seen an example.
I was going to say, I'll share my.
Oh, okay. Sure. I'm not going to force it if nobody wants to.
I went kind of overboard with mine because I spent time like.
Good.
So I got the laser on the left that is basically making it like a rectangle class with some instructors. And then I have a little flow with different content. Over here on the right is the rectangle class. It's got the logic after that printed out in the correct size. This one, like I said, is set up to fit in the loops open, so I'll do something.
A whole bunch. Yay. So let's look at your nested loops there, if you don't mind.
Yeah.
Thank you.
Here is the original full loop. One row at a time. So it'll start on the top row, and then inside of it, it'll write the symbol, and then it's got a nested if else loop that's determining whether it's the top row or the bottom row. So if it's either the top row or the bottom row, it'll print out a solid line of asterisks or whatever symbol it is. But if it's not, then it'll print out
That's good. Does it look good? Any questions? We've got it. Thank you. Any others? Did somebody do it without using a class? Let's see.
So I did I have it where you can insert the two variables for the length and width, and you would adjust it doing the end length, the end width variables. And then I used the 2 for loops to adjust the height and width, and I had a if else nested loops to adjust for the empty space. So if you run it and you say you want width 5 or length 5 and then width 10, you'd be able to do that, or length 10 and width 5. Oh, you can't see it.
I'm glad you figured that out, because I was like, wait, I'm missing something. I kept trying to find it. Jumped over on some other monitor or something is what I figured. Here it is, yay.
looks like you're probably
Yeah.
Didn't do it nearly as pretty, did it?
And you do that.
Ooh, nice.
And then again and insert literally any number. And well, you would be able to, but the space not be.
We could see it. Awesome. Keep that up there for us just for a second, if you would. One thing I wanted to ask you guys, if you notice, they both, even imagine somebody who did the separate class. We usually have the prompts for the size in our main, and then we would have our class accept that input. Now, I've seen some people write code where they prompt for input in their class code, and there's nothing against the law about doing that. It's kind of a convention. And the convention is we want to keep our user input separate from our business logic, which in our case is creating a rectangle. So if we are going to communicate with the user, we want to do that from our main method, our tester class. And then in our rectangle class, we'll just do the actual work of creating the rectangle. So if you've noticed that we're ending up with that input kind of someplace else, that's why we really do want that user input to be separate. And if you think about it, as time goes on, you'll know why. Because our user input is usually going to be in some sort of website running on their computer, right? That's going to be their front end. That's going to be our user experience. Then the back end is usually going to be business logic that's running on some server somewhere. That might be C# code, could be Java code, could be some other programming language code. And that back end is usually going to communicate with another database server. So we're usually going to try to keep those three separate pieces and pretend that we have three separate pieces even if they're all running on the same server, so that theoretically we could split them up if we needed to. And the reason being, we want to separate those resources. If our back-end process, if our creating rectangles gets to taking up so much resources that we can't run it on the same server as we run the database, then we can just separate them, or we can give our server that runs our rectangle class more resources without affecting everything else. So just over time, that's how that's evolved. Now I've got him stuck here because I want to see if he can remember how to bring up a breakpoint in the debugger. Do you remember?
Breakpoint in the world or the
Anywhere, yeah. Let's create a breakpoint using our debugger tool. And that's really what the section is this week. You have a unit exam and thrown a little bit of material in there at you. Well, that little bit of material is about using the debugger. So it should be stuff that you've seen a little bit. Let's set a breakpoint. And yeah, we can do it in so many ways. Let's do it up here so we can see your beautiful loop execute. So you can come way over to the side over here and click in this gray bar, and that'll put that little red spot that's a breakpoint. Or you can like right click on that line and say set breakpoint. But once we've got our breakpoint set, it'll show up red on that line in Visual Studio. Now let's run our program. And if you guys have anything open, you can try using the debugger with it. It's going to type in a number and another number. And now we're to that breakpoint. So execution has halted, and Visual Studio is sitting here saying, I'm ready to run this line of code whenever you tell me to. Now, we can tell Visual Studio to run that line of code a lot of different ways, but our controlling icons are up here, these little blue arrows. And usually we want to use the one that says step into, which should be F11. So we can press that step into, or we can press F11. And what that will do is execute that one line of code and then stop at the next line, ready for us to execute it. Now, down in here, we should be seeing some windows. Are you seeing any of those? Oh, hey, that's what we wanted, that local screen. Now, sometimes he's looking at autos. If you notice there's tabs down here, if you can see way down here, auto, locals, and watch tabs. And as you're reading through the material, you'll see they move you to those different tabs to try different things. But basically, when we're looking at our autos or our locals, we're seeing all of our variables in our code and what their values are. And we don't have to use this window down here to see that. We could mouse over our width variable, and it would show us what the value is of that right now. Okay, so let's go ahead and step into. And step into again. Now he's in this for loop, right? And so if he keeps pressing F11, notice how it's going to show us each part of the for loop separately. And if he keeps pressing F11, he's going to go into his inner for loop. And he can keep pressing F11 to move through that code and watch how the columns variable is changing values, the row variable is changing values. And if you will do this, you will probably get a better understanding of what's going on in your program if you'll use the debugger and just step to the point where you're kind of getting a little cross-eyed, but you're still just seeing it happen and you're like, oh my goodness, I see it, I see it, I see it. And that's what we want. Now, some people don't need to do this. Some people can just see things. Some people can just see things without having to actually step through it. But it's very helpful if you'll just kind of step through it. Now, one of my worst things that I hate, my worst hate thing, is when I hear a student say, I don't know why it did that. Well, who wrote the program? You should know why it did that. And if you don't know why it did that, step through it in the debugger and figure it out. Why did it do that? Because this is where you get to control all the code. In the future, you might be changing other people's code, and then you really can say, I don't know why it did that, because it might be really hard to figure out what in the world they did. But when it's your code, you should be able to step through it and figure it out. Anything else? Can you notice anything awesome there? The other icons besides step into, we have step over, which will bypass letting us, giving us a visual on some code. What else is there? Step out, where we can exit the debugger and just continue executing. And then the last one should be to go backwards, which is so new. I don't know how new it is, but actually it's not something I've used a lot because it is new. So it's very cool, and I think that it's something I've wanted to do many, many times and couldn't. So that's what your new material is this week, is kind of looking at the debugger, getting used to troubleshooting and all of those. Thank you so much. You can close that thing. Thanks, you guys, for showing us. And anytime we're working with loops, the debugger is just a great tool. So today, let me get this up here. We're looking at if statements, but our if statements, if you remember, since our condition is so important in if statements and in loops, we'll do this activity, but it'll help us with looping also. I haven't told you who your table partner is yet, so you can't do that part. We'll do that together. I keep forgetting to email them and tell them it won't let me kick. I need to tell them. All right, so what we're gonna do here, you're gonna get a partner if you didn't figure that out. You and your partner are gonna be assigned your own specific color of Post-it notes. So if I were to give you and your partner the pink ones, you are the only ones that have the pink ones. You don't have to worry. No one else is going to have your Post-it notes. So what you're going to do with your Post-it notes then, you and your partner are going to go around to all of these posters. And all these posters have a code snippet printed out on them. And the code snippet includes some sort of if statement. And you guys are going to decide what the output would be from that code snippet. You're going to write that output on the back, on the sticky side of the Post-it note, so that when you're done, you can stick it to the giant Post-it note and you'll be able to tell, oh, we already did that one. Our pink Post-it note is already on there. But we don't want your answer showing up to other people because we don't want them copying from you your answer. So everybody's going to have a partner and everybody will have their own color Post-it notes. And I have posters stuck all over the place because this room didn't have very good spots. So like they're hanging off of things and stuff. So be careful to try to find them all. Let's see how many different groups we have. But when we're done then, and we've got all of the different if statements answered, we'll have some people go around and be our graders. And we'll look at what the right answer is for each of these. And they're going to bring all of the correct answers up here to the front and create a kind of like bar graph of different groups. So we know which group is like the awesomest. Now our orange group this morning was pretty outstanding, and so was the pink. I'll get these out of your way. I just wanted to leave them here so that you could see in the end result. That was kind of what we wanted to see. So I felt like they did pretty good. I did too. I felt like everybody did really, really good this morning. Okay, and I bet you guys will do even better. So the way I split them up, do the same thing here for us. This area over here, I'd like you to come over here and line up, and I want all of our only children up here in the front, and then I want everybody to line up by the number of kids in their family all the way back to back. And you, it doesn't matter whether you count step brothers and sisters or not. None of us will call you a liar. That's totally up to you. But I want these only children up here in front so we can partner them up with people that have other family members. You're the only one. We don't have any only children. Sorry, I didn't say that. Only children are fine. I count 16, so I'm going to go to 8 twice. So let's see, it'll be 1, 2, 3, 4, 5, 6, 7, 8. 1. Come on around and find 2, 3, 4, 5, 6, 7, 8. Oh my God! Okay, let's see. Okay, group number 1, you guys. Orange. Oh. Group 2.
That's us.
Group 3. Green. And 4. Blue. Okay, now the rest of you get the camo colors. You guys can go ahead and get started if you've got a color. Make sure nothing matches. Okay, we have 12 colors. All right, everybody's so proud of it.
Yeah, that's it. Yeah, that's all right. Okay, so
What fell? Oh, did it? Okay, don't worry about it then. I tried to not touch it. It's just my hand back here. Don't worry about it. After I go through these out, I'll fix it. Okay, let's keep going on this thing. And we'll ask people to grade our sheets that are close to them because they're all kind of scattered all around. So you guys will have to look. This was my instructions that I wanted you guys to move clockwise throughout the room. And I just gave that up pretty quick the first time I did this. So just ignored that one. But now we're ready to grade them. So when you grade, just take off the Post-it notes that are right and bring the ones that are right up here, and we'll put them on the board to create that nice bar chart. You don't have to worry about your color because nobody's really going to be thinking about what color you had. So that's what this activity is for you to get some feedback and know how well you did, but not be embarrassed. All righty. What about number 1? Does anybody see this poster? Where is it? It's right there. Can you guys grab it? Someone close to it. Can you grab it? Oh, yay, thank you. Okay, so in this one, we've got a student age, and we set up the variables before we went into our main logic, saying that it was 14, and the entrance fee was 0, and the student eligible flag was set to true. So if the student age is greater than 18, is that one true? What about if student age greater than 14? Is that what true? No. So we would be this one, greater than 10. So that's the output that we should have seen, and the output down at the bottom after the if statement, right? So we should see entrance fee for a student that is 14 years old is $2. Above that should say student is eligible. Yeah, start checking them. Now, since you're grading, you can decide, you know, if you see that a bunch of people put something wrong, but you're going to give it to them anyways, that's fine. You have that ability as the grader. Only perfection from him. Okay, where's number 2? While he's grading that one, let's find number 2. You see it? Oh, you got it. Okay, great. Now, number 2 is a little bit different. We started with a variable input number set to 7, and then we called it double it method. Is that the name right? No, it's not, is it? Could you depend on previous programmers to name things right? No, they're going to do just like this, aren't they? So we had to kind of actually go through the code, because if we would have assumed that it was just going to multiply the number by 2, we would have been kind of wrong, because double it actually takes a number to the power of 2. So it should be named something different, like square it or something along those lines. But we're just at this poor programmer's mercy. So we go into this routine, we square the number, and then we are comparing it to different values. So we should end up with 49. So the first if statement should fail. The second if statement should be true, and we should have over 40 output. What about the next if statement? It would be true also, so we should also see over 30 output. So let's make sure on that one. I've got the answers where I ran them, because sometimes they don't look like they're gonna do what we think. Thank you. Okay, we got some going now. What about number 3? Where is it? Does anybody see it? No, somebody, oh, thank you. Okay, so for number 3, we have 2 Boolean flags. Is it the end of the data? And is our data valid? Then we have 3 strings that are set up to hold messages. And in our if statement, the first thing we do is check to see if is end of data is what? Not true. So are we going to execute this if statement body? Yes. Now, inside of it, we're going to check to see if our is valid data is true or false. Since it's false, we should output the data is invalid. Does that make sense? So this one isn't as complicated as some of the others, but I wanted you to think about using variables like that. The data is invalid. All right, what about number 4? Can you find it? Number 4. Oh, they found it. All right, and number 4, we're checking the student age. We're doing a range check here. Whenever we're checking for this student age, is this if student age greater than 17, is that true? No. So are we going to drop through and execute this else? No, why not?
We gotta check that line.
It's going to what? Check the or. So is student age less than 19? Yeah. So we're going to get student is 18 and eligible. Is that correct? Probably not. It looks like a little bug, doesn't it? Okay, he's already got that one. He was like, I'm ready. What about number 5? This is I like to call this meme math. Is that what these are? Meme maths? Because you guys get them broadcast at you all the time. What's 5 plus 5 times 5 times 5? Okay, so that's what I thought I would give you. What's a bunch of 5s added and multiplied? Is it greater than 6 to the power of 2? I'll let you think about what you decided. And the answer is the number 35 is less than or equal to the number 36. Okay. Thomas, everybody's got it?
Yeah.
Woohoo! Okay, what about number 6? This is that one you guys did really good. Usually I have a few people pull me over to show me the syntax errors in this one and say, is this one something you meant to have syntax errors? No, it's valid. So what's going to happen in that one? What are we going to print out? Grade is C, because we're doing one of those ternary ifs here. So our grade variable is going to be set depending on whether exam score is greater than 89. If it's greater, we would give the exam or grade an A, otherwise a C. So we should see grade as C. Good job. Good job, seriously. Just, I'm not gonna come anymore, you guys have this. Okay, poster number 7, sit anywhere around. Our back row is gonna get hit hard. Back row people yell at these people in front of you and say, you come do this. Okay, this one is good because we're using a switch case. And in this example, we have an integer that's holding a score of 67, and we're going to divide that by 10. So what's our exam score going to end up being equal to? I hear it. Yeah, but what's the number? 6. So we're not going to get 6.7 or 7. It's not going to round. You're exactly right. So yes, grade is F. is what we expect to print out. How about number 8? That's right behind Jackie. Oh, thank you, Mohammed. That's very nice. All right, for number 8, we have a parking fee here, and we can either pay parking for the semester or per credit hour. So if we pay per credit hour, it's $10 per credit hour. So our if statement is checking to see if this semester fee is less than our credit hours times our per hour fee. So we should see in that one that it would be best for us to buy a parking thing. Where am I? Buy a permit for, is that right?
Yeah, because you have the per hour fee for the semester.
Yeah. Kind of weird. Like to give you weird things. Now these candy ones are some of them are kind of buggy. Or like not too good. But they're really, really important for you guys to think about these variables. So what I have here is my candy company has set up all of these constants. And I could use these constants in every single program. Getting it fixed. Go. Every single program I write in my company, I could say premium candy is a P, regular candy is a R, ship UPS is a U, and ship USPS is an S. So these are like my code table, my lookup information to find out. Now, in our actual program here, we're starting with our cost of 0. We're using a candy type of R and a shipper of U. So this very first if statement, if candy type equals premium candy. Is that one true?
No.
No? So does any of the rest of it get executed at all? So we would drop all the way down here to this last statement. The cost is, what are we going to get for a cost if we didn't execute any of that other code? Just get a 0, right? So now in this case, though, we're going to get something a little different. And you can see how the switch case lends itself to using those code constants that we were looking at. Makes a little more sense when we look at a switch case statement. Here we're switching it up by candy type. And if our candy type is the same as our premium candy flag, we're setting our cost to 35. If it's the same as our regular candy flag, we'll set it to 25. And then we're going to do the same thing with our shipper. Add or change. So with this version, we should end up with the cost of $35. What about this one? Is it buggy? Let's take a look. This one's correct, right? We take our candy type to get our cost, and then we add our shipping to our cost. What about this one? So it's going to wipe out our shipping cost, right? Since we're doing this addition up here in the wrong place, we're going to wipe out our shipping. Exactly right. But so for this one, the output is going to say the cost is $25. Okay, what about number 12 here? We've got a student age of 16 and an eligible age of 17. So is the student eligible or ineligible? Eligible? Why? Don't they all have to be true though?
Yes.
Isn't that if?
Yeah, an eligible age of 17 because you adjusted.
But my other two, we just have to be true. This have to be true too. Since they're ands.
Needs to be greater than 15 and less than.
So it's all true. All looks good. Very good. Wasn't with him. Very, very good. All right, what about this one? Our number attending is 5. That's a weirdo, isn't it? So here we're saying we want to output a parameter. Our parameter is going to be determined by this ternary if. So is the num attending less than 3? No. So we would use the 25, true, false. So we should get the entry fee is 25. Those ternary ones are really a bear, and that's why I gave you a couple of them, because they're like, what? But seriously, usually every semester people pull me over to them and are like, there's a typo here. Did you want this to be 2 equal signs? Did you want this colon to really be in this statement? And you guys just went right through it and were like, this should mean something. So good job. Let's see how this is going. He's finishing, yay. Can't get them all on here. There's so many ready. Oh my goodness. Did the oranges and pinks take it again? Oh, I don't know. That aqua blue is very, very. And the blue.
The puke green.
The puke green is pretty good too. And the pink is kind of good. Whoa, look at that. Like almost everybody just did amazing. I'm gonna have to make them harder. You guys gonna have to find harder ones for me. They used to be too hard for everybody, but now you guys are like, this is easiness. Okay, really, really, really good job. I remember one semester there were like 3 up there, and I was like, oh God, I guess we gotta do if statements again. Do we still have one? I'm done. Okay, let me do this last one. I was getting done before I should. Okay, what about this one? And this is a good one too, because again, we have a switch case and we're looking at a reason code. We have some sort of return to our company and we want to know why. Was that a reason code 0 or 1? So based on our reason code, if we had an error, which it says we did, we're going to do this if statement stuff to decide what the refund should be. Otherwise, we're just going to give them like 70%. And then we're going to print out that refund amount. So the refund percent is 5%. And it's printed weird like that too, with the formatting that was in that 5.00 and then the percent sign. Okay, now let's see how that goes with this one. I think we have some competitive souls wanting this last one to go up there.
Yeah, and I said we should have gotten it because like the out of 100 at the time.
The only important one is the aqua color.
Oh, God.
He can't find it. He's like, wait, that goes this way. Oh my goodness. The blue green. He says it's a puke green. Pretty good. I think it is. They're all so close. So we have some people that I think got them all right.
Blue and pink tie, and then orange and this pink tie, and then this one's first.
Awesome. You guys did so good. Okay, so I was going to wait till next time, but I think we'll go ahead and do this. Some of you guys have already heard about this. Rubber duck debugging is a process wherein a developer uses a small thing like a rubber duck to try to do troubleshooting. Here's one, my little gray chocolate duck that hides up there. And so the theory is, now I'm not going to make you talk to them today because we don't have a lot of debugging to do today, but the theory is, as a developer, there are lots of times you just want to talk out your problem, and I can tell you, there are lots of times you want to talk out your problem to the point where you will grab your friends and you will just say, just listen to me, I don't care if you know anything about it. And they'll be like, I don't want to. And that's why you have the rubber duck, because that way you don't do things like that to your friends and you can just talk about it to the rubber duck. And what they found is, if you talk out problems like that, even if you're just talking to an inanimate object like a rubber duck, it helps you solve the problems. Hence me grabbing that friend and saying, just sit right here and let me talk to you. I knew it didn't matter if she knew what I was talking about. I knew she just needed to sit there and listen, and I would figure it out as I explained it to her. Somehow that wasn't fun to her. I don't know why. But your rubber duck will think it's super fun, and so you can sit and talk with your rubber duck and get everything worked out. Now I have some for you. So you have to come pick one out. Let me get them over here. And then we'll have our debugging ducks for our debugging section here. I'm going to set them. We use this table. Okay, so there's some in the box. There are some in the bag. There are a lot of things. There's no why. Come get it up. That morning class is only going to have pink ones left.
Like something super little semantic. No.
I think the big thing is being able to even get close. Seriously.
Oh, I patched up.
I'm gonna add to my camel collection.
Awesome.
She gave me a camel one out there. So every time I just get a camel.
That was cute enough. Oh, no, it's good. It's like a bunny duck.
I know, it's so cute.
I don't know how this weirdo assortment does.
Better than last time when you had like 5 of them with like bikinis.
I know, I'm like,
They're so
they just send you really weird assortments. Like when you order them off Amazon. The weirdest assortment of rubber ducks. Can you imagine if you had a kid? Here, I'll just make you that. So fun. Okay, you guys are, it is lab time. You just have about 30 minutes left. Finish up that repetition lab sim. Let me know if you need help with it. The newest lab sim that is the troubleshooting one is open, but you might want to wait on it till Wednesday. It's pretty quick. I think it's just like 1 or 2 activities, so it should go real quick. But that's us for labs. Let me know if you have any questions or anything. Everybody good? I did great. Yep. Sorry, I said some other word probably.